In this unit, Understanding Learning and Memory, we will review key theories, concepts, and strategies related to learning and memory. In order to best serve learners, it is vital to understand the human processes that lead to learning and memory formation. This knowledge will enable you to optimize instruction, create interventions to help students, and enhance your own learning. Please pause the video lesson and take a moment to read this unit's learning outcomes. We'll come back to these outcomes throughout the lesson. With advancements in neuroscience and educational psychology, we're learning more and more about how people learn. Take a moment to look at these 4 common beliefs. Are they facts or myths? The third assertion, that our brains continue to develop and grow into adulthood, is actually true. The rest are myths. We used to believe that our intelligence was fixed and that we were born with all of the neurons that we would have in our lifetimes. In fact, brains continue to change into adulthood according to how we use them, thanks to a concept called neuroplasticity. These 2 statements represent 2 different beliefs about human intelligence. Take a moment to pause your video and see which one you agree with more. We now know that the statement on the right, that intelligence is malleable even into adulthood, is the truer statement of the 2. Our intelligence can actually be developed and affected greatly by our efforts. According to Dr. Carol Dweck, these 2 statements represent 2 different mindsets that are crucial in individual learning. The statement on the left is indicative of a fixed mindset because it says that intelligence cannot be changed. The statement on the right, which says that intelligence can be changed through directed effort, exemplifies a growth mindset. A person who has a fixed mindset is going to behave very differently than someone who has a growth mindset. As you might imagine, having a growth mindset is much more conducive to learning. This graphic provides a more detailed overview of the difference in behaviors related to fixed and growth mindsets. You see, having a fixed mindset causes individuals to believe that they were born a certain way and that no amount of effort can change them. Thus, a fixed mindset prevents learners from seeking challenges or applying effort because it would reveal their weaknesses and end up fruitless. Due to this idea, people with fixed mindsets tend to lack confidence in their abilities, receiving feedback and failure with difficulty, and blaming their abilities on others when things don't go their way. On the other hand, individuals with a growth mindset believe that improvement and mastery is always possible with hard work. Thus, they embrace challenges as opportunities to grow, persevering through obstacles. Directed effort is believed to be the means through which individual growth is attained. With this mindset, feedback and failure are welcome events along the path to mastery. When individuals with a growth mindset hit a setback, they blame their effort or motivation and decide to work harder, instead of blaming their intelligence or ability and getting down on themselves. You might be wondering, why is this important to understanding learning and memory? The big takeaway here is that we can greatly influence our intelligence and growth through effort. It's this idea that new neurological structures can be created through directed effort that underpins our understanding of learning and memory through the information processing system, which we'll cover in the next slide. Now that we've established that intelligence is malleable and new learning is predicated on effort, let's examine the processes that lead to human learning and memory formation, the information processing system. This theory represents foundational knowledge upon which much of our course content will build upon. The information processing system, or information processing model, consists of 3 main components: short-term memory store, working memory, and long-term memory. The short-term sensory store, also referred to as sensory memory or the sensory register, is the first component of the information processing system. This is where information from the environment enters our minds. What kind of input goes into the short-term sensory store? Well, imagine everything that you might be sensing as you head to class on campus. What do you hear, see, taste, touch? Everything that your body can sense from the environment enters your sensory memory. What happens to information in the short-term sensory store? It's either moved into working memory or it's lost in a very short amount of time. That's why this component is often referred to as a store and not memory, because of the quickness that information is lost. In fact, if information is not moved into the working memory within 0.5 to 3 seconds, it's lost, gone. This also results in a lack of conscious awareness of the information that's passing through the sensory store. Think about all of the people, buildings, and objects you pass on your way to classes on campus. All of the conversations you heard, cars you sat next to in traffic, or activities that were taking place. All of these pass through your sensory register, but most do not make it into your working memory. In this way, our sensory memory acts as a filter that prevents our consciousness from becoming overwhelmed by the environment. But how does information get into the working memory? Let's take a look at that in the next slide. You have to pay attention. I'm talking about working memory, of course. We must pay attention to information in order to move it from the short-term sensory store to the working memory. An example might be you walking across campus, tuning most of the environment out as you make your way to class when you see someone wearing the same USC shirt as you. You pay attention and pull it into your working memory, not necessarily transferring it into long-term memory because it's really not that important. The same thing can happen in a lecture. You must attend to the information at hand in order to work with it, otherwise it's lost. There are 3 things that can happen to information in the working memory. Information is either lost, information can be repeated or rehearsed and thus kept in working memory. For example, remembering a phone number or someone's email address, or information can be transferred to long-term memory. How do we move information into our long-term memory? We'll get to that shortly, but first, let's take an even deeper dive into working memory. Think of working memory as our consciousness. Once we attend to information, we can think about it on a conscious level. Unfortunately, our working memory is extremely limited. We can only think of about 5 to 9 things at a time, and many experts believe that that number is actually lower. Our working memory has a very small capacity and a very short duration on top of that. If information is not rehearsed or repeated, it only stays in our working memory for 5 to 15 seconds. Once new information is attended to, oftentimes something else is pushed out of our consciousness or working memory, meaning that memory is lost. For example, you and a friend might have been having an interesting conversation while sitting outside of Leavview Library when another group of people nearby catch your attention with their conversation about a concert they went to for your favorite music group. If you start to attend to their conversation, oftentimes your thoughts about your current conversation with your friend are pushed out of your working memory, and you cannot remember what was just said or what you were about to say. This also happens when you're studying and trying to attend to information in your notes, a book, or a recorded lecture like this one. There may be music playing in the background, which might have not been distracting you until a song that you really like comes on and pulls your attention away from the notes. Or maybe it's a song that you've heard so many times and you want to switch to the next track, so your attention is pulled away because you want to change the song. You can't just pick up where you left off studying. In order to come back to where you were, you have to figure out where you left off and quickly review the information that you were just working on before you can proceed. This may only take a few seconds, but this type of task switching can actually task or fatigue our executive control system. The executive control system is one of the 3 components of the working memory. This is where we process things consciously and make meaning out of the information that we attend to. The executive control system organizes information and makes inferences about it in order to make the new information meaningful. The executive control system also decides which information we will attend to, which will be rehearsed, which will be sent to long-term memory, and which will be deleted or lost. Please take a moment to pause your video and consider the questions posed here in addition to their implications for your practice as educational counselors. Now that we have an understanding of how information makes its way through our short-term sensory store into our working memory, let's examine the third component of the information processing system, long-term memory. Long-term memory is the promised land, the gold standard of memory. This is where learning occurs and where we want information that we're trying to learn to end up. But in order for information in long-term memory to be useful to us, we need to be able to bring it back into our working memory when we need it. For example, in a test or in our professional practice. How can we ensure that that happens? What we need to do is encode the information by making sense out of it through our previous experiences or prior knowledge. The information needs to be organized, which means that it is associated with other information that we already know that can help lead us back to the newly encoded knowledge. This is why we say that information should be encoded into long-term memory versus simply deposited. A useful metaphor for encoding information in long-term memory is cleaning up a messy room. Imagine being a kid wanting to go play outside, but your mom says that you have to clean your room first. Like most kids in this scenario, you hastily take everything and stuff it into your closet. Feeling accomplished with the completed task, you head outside to play with your friends. Unfortunately, later on, when one of your friends asks to see your limited edition fidget spinner, you have no idea where it is. You know it's somewhere in your closet, but have to pull everything back out in order to find it again. Mom comes in to see the mess, and it's back to square one. Now think about how this compares to cramming information for an exam versus taking the time to organize it well, making sense of it as it relates to your prior knowledge and experience. What happens is that information is simply stuffed or deposited in your long-term memory, making it more difficult to retrieve that information when you most need it. Have you ever spent hours studying for an exam the day before a test, but just can't seem to remember what was studied when it's needed? One of two things have happened in this scenario. Either the information was hastily crammed into long-term memory and we're unable to retrieve it, or the information never made it into long-term memory, as we simply rehearsed the information in our working memory without encoding that information into our long-term memory, and it was lost when we stopped thinking about it. This begs the question, did we really forget what we learned, or did we not learn it in the first place? This storage and retrieval aspect of the information processing system is vital to keep in mind. That new information must be prepared in working memory to be encoded into long-term memory, and that, in turn, old information must be retrieved from long-term memory back into working memory to make it useful to us, both in terms of its direct utility for a given task and relating it to new information to make that information more meaningful. This process of storage and retrieval is greatly influenced by information that is meaningful, or purposeful and relevant to the learner. It's also influenced by information that's organized, making it easier to learn and recall. Good examples of organized information are graphic organizers and outlines. Elaboration also greatly influences storage and retrieval. This is the process by which new information is linked to what you already know. Through these processes, we create and build upon what are called schema structures in long-term memory, or large structures of information that make that information more meaningful and easier to retrieve into working memory. For example, imagine that you're tasked with writing a research paper. Do you have any existing schema structures that might help you organize the paper without even knowing its specific content? So how do we maximize our limited working memory while ultimately supporting our long-term memory in being able to encode and retrieve information effectively? Well, we have to make sense of it, organize it for ourselves, and take the burden off of our working memory as much as possible. This matrix here represents a good example of just that. This graphic organizer will help you in remembering all of the information from the previous slides on the information processing system. Here is a comparison of the three components of the information processing system: the short-term memory store, working memory, and long-term memory, comparing their respective capacities and durations. You can see how we've taken a lot of information from the previous slides, condensed into one slide so that we can compare and contrast it, make sense out of it, see the relationships between the three components, and make sense out of the whole information processing system and its impact on learning and memory. Please take a moment to review the matrix. Let's pause to ensure that what we've learned so far matches up with our learning outcomes. Please take a moment to pause the video and review what we've learned about the information processing system. Can you identify how the information processing system explains learning? Now that we can identify how the information processing system explains learning, let's dive a little deeper into how to maximize its potential. Here, it's important to understand the difference between rote and meaningful learning strategies. Thinking back to the information processing system, we can identify that rote learning takes place in the working memory in the form of rehearsal. Here, information is simply kept in working memory through repetition, but never encoded into long-term memory. Meaningful learning, on the other hand, takes place in the form of elaboration and organization. This is where information is encoded into long-term memory to form meaningful schema structures that are available for easy retrieval. Can you identify which strategy is more conducive to learning and why? Here are specific examples of the learning strategies discussed previously. Again, rote learning consists of rehearsal, where information is simply repeated in working memory to keep it available. Examples of rehearsal include copying another person's material, taking exact notes from a board or lecturer, underlining or highlighting important content, or reciting information over and over again. These strategies might be useful for working with information in the moment that it exists in your working memory, but they do not encode that information into long-term memory for later use. On the other hand, elaboration and organization are meaningful learning strategies that encode information into long-term memory. Examples of elaboration are summarizing, note-making, which is distinctly different than taking verbatim notes, and answering questions. With elaboration, you're chewing on new information to make sense of it according to what you already know or have experienced. Examples of organization are outlining, creating representations such as graphic organizers, and finding main ideas. Organization works well because it reduces working memory load by reducing the number of units, essentially chunking large quantities of information to make them easier to recall. Please take a moment to pause the video and think about what we discussed about rote and meaningful learning strategies. Can you discuss the difference between the two strategies? Another one of the main theories that we'll draw upon in this course is the social cognitive theory. This refers to a psychological model of behavior that emerged primarily from the work of Albert Bandura in the late 1970s and 1980s. As the name implies, social cognitive theory emphasizes that learning occurs in a social context and that much of what is learned is gained through observation and modeling. This theory rests on several basic assumptions about human learning and behavior. An important assumption is that a person's ongoing functioning is a product of continuous interaction of personal, behavioral, and environmental factors. Here, there's an emphasis on the reciprocal nature between a person's cognitive functioning, their behavior, and the environment. For instance, learning in any given environment is shaped by factors within the environment, especially social factors such as reinforcements experienced by oneself and others. At the same time, learning is affected by the learner's own thoughts and self-beliefs and their interpretation of the learning context. Thusly, behavior is a result of the interaction between people and the environment, in that their internal thoughts, combined with the social influences, lead to behaviors that further influence the environment and the internal thoughts of themselves and others in the environment. This sort of interaction is known as triadic reciprocity. Let's apply the model of social cognitive theory to an example. Let's say we're looking at your learning process as a master's student and the things that might influence your learning in the program. There are a variety of environmental influences outside of you that may influence you, such as feedback from instructors, job demands, peer and family support, and certainly support from the program. All of these factors have an interactional relationship with your beliefs and perceptions, as well as your behaviors. Your beliefs include your self-efficacy, your goals and emotions, and your behaviors, how you manage your time, whether you seek help, and other behaviors. Let's look at another example. Let's say that a student comes into the EC program with low self-efficacy in terms of their writing ability. The student comes into the program highly anxious about their writing and ability to complete the program. Because of this low self-efficacy, the student seeks out help from the instructor in their writing. In other words, the personal factor of low self-efficacy influences their behavior. This behavior of seeking help then increases the feedback that they receive on their writing. The feedback is an environmental influence that in turn increases their self-efficacy, but also increases future behavior by encouraging the student to seek additional help. The continued help seeking also helps the student feel less anxious. Again, note the dynamic nature of this model in terms of the reciprocal nature of the influences in this scenario. When changes are made in the environment, it not only affects behavior, as we see in behaviorism, but that change in behavior also reciprocally influences the environment. In this case, the quality and quantity of feedback from the instructor. If an instructor sees improved writing partly due to feedback provided, he or she is also likely to continue enhancing the quality and quantity of feedback provided. Of course, all of the activities just discussed occur in the socio-cultural context, with all of us bringing influences from our different cultural backgrounds and the cultures that emerge in each of the classes that you will take. For example, one course's culture may emphasize the importance of high grades, while another may emphasize applying what is learned to your professional context, so actually mastering the material. Another course may make it clear that you're expected to seek help as you need it, while still another may send the message that you need to find answers on your own. These different emphases create different course cultures that add a layer of impact on a learner's cognitive and behavioral processes, which in turn impacts the environment. According to social cognitive theory, learning is enhanced by the meaningful learning strategies discussed previously in this lesson. Modeling is a highly effective form of observational learning, especially when a model is competent, credible, similar, and enthusiastic about the subject matter. For example, this week's reading on social cognitive theory put forth the assertion of some theorists that children are only influenced by television characters that they can relate to. It is also important that learning content be made personally relevant or interesting to the learner, that learners have ample opportunity to rehearse, elaborate, and organize information, and that learners receive specific, immediate feedback on their learning task performances. These factors act as environmental influences on personal thoughts and behaviors. Let's do one last learning outcome check. Please take a moment to pause the video to reflect upon social cognitive theory. Can you articulate how social cognitive theory explains learning and behavior? Be sure to take the quiz before you come to the live session on campus. Remember that this time the quiz is graded. Come to the live session ready to discuss the assigned readings and reflect upon how this lesson's content might impact your current or aspiring practice as an educational counselor.